So let's take that statement that said, take the base raised to the power of the opposite side equals the argument. And let's apply that now. So I want you to notice what the directions to this problem state, though, so we know when we want to do this. The directions say write the equation in exponential form. So what we're doing here is we're taking a completely true statement and we're rewriting it as a completely true statement that just has exponents in it. So I really want to point that out. These are what I like to call jumping jack problems. If you think about what a jumping jack is, you spread your legs out, you raise your hands up and touch them, and then you get back to where you started. The actual action of doing that is kind of stupid. You're not really achieving anything, but the process of doing it is what's important. You can use jumping jacks as a warm up before a workout to get your body temperature stepped up, to get your heart rate going, and even stretch yourself out a little bit. You can also use a jumping jack as a cardiovascular exercise to, again, get your heart moving. And if you do a lot of them, you do them with intention, then that's going to be a good exercise. But the end result is nothing. You just get back to where you started. And that's kind of what's going on here. We're going to take a completely true statement and end up with a completely true statement. But the purpose of this is going through the motions to get yourself used to using this rule. So the rule again was to take the base. The base of my first thing here is 5. We're going to raise that to the power of the opposite side. The opposite side is 2. So we're going to raise it to the power of 2. And that's going to be equal to my argument, which is 25. Now, the reason I like to start off doing these types of problems is because we can very easily check our answer by saying, is that a true statement? We started off with a true statement, so we should probably end with a true statement. And so sure enough, 5 squared really does equal 25. We don't want to simplify this at all because that was the whole purpose, was to write this as an exponent. So even though we could simplify the left-hand side to 25, that's not helpful. We wanted to write this as an exponent. So similarly for our second problem, we're going to take the base. That's 6. We're going to raise it to the power of the opposite side. We're going to raise it to the -1. And that's going to equal our argument, which was the 1/6. Again, the argument is what we're taking the logarithm of. And when I have 6 to the negative first equals 1/6, I can again say, does this make sense? Is this a true statement? And yes it is. Negative first power means take the reciprocal. Now to wrap this up, the last one, we take the base. The base is 2. We raise it to the power of the opposite side, which is 1/2. And that should be equal to the argument, which in this case is √2. And once again, we can say, is 2 to the 1/2 power really the square root of 2? And yes, that's the definition of the 1/2 power. So that does work out.